Welcome to our lecture on the nature of materials. Understanding types, composition, and bonding of engineering materials is a fundamental materials science and engineering. This knowledge enables engineers to select appropriate materials for various applications, ensuring performance, safety, and cost effectiveness. Metals. These are typically strong, ductile, and good conductors of heat and electricity. Metals are subdivided into ferrous metal, certain iron, example include steel, cast iron. Non-ferrous metals do not contain iron, example copper, aluminum, and titanium. Polymers. Compressing long-chain molecules, polymers generally lightweight, corrosion resistance, and electrically insulating. Example include plastics, polyethylene, and polystyrene. Ceramics. These are non-inorganic, non-metallic materials that are typically hard and brittle. They have high melting points and are good insulator. For example include porcelain and silicon carbide. Composites made by combining two or more different materials to achieve properties superior to the individual components. Example include fiberglass, carbon fiber, reinforced polymer.
Hello everyone, I am Nick Chibon P. Valenzuela and I will be the second reporter for this topic. Thank you. Second topic, which is titled Engineering Materials. So what is engineering materials? Engineering materials are substances used in manufacturing of machines, structures, and components. Understanding the composition of these materials is crucial for selecting the right one for a specific engineering application. Their composition determines properties such as strength, durability, conductivity, corrosion resistance, and weight. So, engineering materials can be broadly classified into four main categories based on their composition and structure. So, the first one is the metals and alloys. So, what are metals and alloys? Metals are typically composed of one or more metallic elements and may include small amount of non-metals, while alloys are mixtures of two or more elements, at least one of being metals. So, further explanation for metals and alloys are: metals are typically strong, ductile, malleable, and good conductors of heat, electricity, and they are used in structure, tools, and machinery due to their strength and toughness. And alloys are formed by combining two or more elements to enhance specific properties such as corrosion resistance, strength, or heat resistance. So the second one is the polymers. So what is polymers? These are composed of long chain of repeating molecular units called monomers. They can be natural or synthetic, and they are usually also lightweight, flexible, corrosion resistant, and low cost. So the types of polymers are thermoplastic, thermosets, and elastomers, and the application for these are used in packaging, isolation, pipes, automotive parts, and consumer goods. So the third one is the ceramic. Ceramic are inorganic and non-metallic materials made from metal and non-metal compounds, usually oxides, carbides, or nitrides. They are also made by heating natural or synthetic raw materials to high pressure. And its applications are for electronics, aerospace, biomedical implants, and refractories. The last one is the composites. Composites are engineered materials made from two or more constituent materials with significant different physical or chemical properties. So the advantages for these are high strength to weight ratio, tailored properties for specific application, and the last one is corrosion resistance. Okay, so let's talk about the importance of materials and composition in engineering. So the performance and suitability of engineering materials are determined by their composition. Examples are strength and hardness, affected by the amount of carbon in steel. So the second one is the corrosion resistance, increased by adding chromium and nickel to stainless steel. Third one is the weight reduction, achieved by aluminum alloys or composition materials. The fourth one is the thermal properties. Ceramic resists heat using in engines or furnaces. So the last one is the electrical conductivity. Copper and aluminum are widely used due to their conductive nature. So before I would end my report, I would like to conclude that engineering materials play a crucial role in design and manufacturing processes. The composition of each materials governs its properties and usability in various applications. A strong understanding of materials composition enables engineers to choose the most appropriate material for durability, performance, and cost efficiency. Thank you.
So, good morning everyone. This topic is all about chemical bonding. So, what is chemical bonding? Chemical bonding is a group of atoms that behave together during a strong structural bonding. And why do chemical bondings occur? Chemical bonding occurs because it needs to find a stable structure to make a strong concrete structure. So, the bonding between atoms and molecules. So, the bonding between atoms and molecules are held together in molecules by various types of bonding, like primary and secondary. In primary bonding, there are three types of bonding, like ionic, covalent, and metallic bonding. Primary bonding is much stronger than the secondary bonding because in primary bonding it yields a strong bonding. So in ionic bonding is transferring of electrons, like methyl or chlorine. Ionic bonding, electrons can be transferred like this. The electrons of the sodium can be transferred in the chlorine. So in a covalent bonding, electrons are shared, not transferred but shared. In a metallic bonding, the electrons of metal or the atoms are shared in vigilance, the cloud vigilance. the process is much bigger. So if the oxygen, an oxygen is closer, the van der Waals process is closer. And means the van der Waals forces are bigger in electrostatic forces that attract neutron molecules to one another, and van der Waals refers to as intermolecular process. So in the intermolecular process, this is the general term for forces to attract and repulsion between molecules, like the attract and repulsion of dipole interactions that has attraction and repulsions. So, in-explain na yan mo to, ang dipole interactions. And second, nasa London forces. London forces is much bigger than is much bigger. So, in the hydrogen bonding is much stronger than the van der Waals forces and dipole interactions. In hydrogen bonding, like an H2O, it bonds with another water to make more water. So if you boil it, the molecules of the water is being added, it will combine. So if you will mix chlorine and fluoride, that is poisonous gases. So thank you